go through the time schedule and give you some further information for the parts. At first, we are now a group of 12 people who organized this event. If you all I think already know, it's a project of two student organizations. First, the ACC2011 Stuttgart, who's a model maker and model aviator group, where you are able to transfer theoretical knowledge in a practical part, and the EuroAvia, a student organization who specializes to get in contact between students and the industry. Just some general organization details. As you already noted, you got all the green participant t-shirts, and we got 3 colors. That's I think it's a little bit more clear if you have any questions or problems. The participants have the green t-shirt, our assistant team, the orange t-shirt, and the red ones for the organization team. So if you got any problems or questions, search one with the red t-shirt, or if you don't see one of them, the guys with the yellow t-shirt should also be able to help you. So, at first I want to introduce you to our jury. Our first member, Professor Gerhard Busse, is worked at the PKB's Institute of Plastics Engineering, is specialized in destructive engineering, and is also a model maker himself, so he knows what he's talking about. Our second member, our jury member from the industries, is Michael Schuler. He studied also aerospace engineering in Stuttgart. He is the CEO of Autogiro, and he was a former president and financial officer of the EuroAvia Stuttgart. Then our third member, Donald Riedeberger, is a EuroAvia member, former secretary of the international board. Now he's doing his doctorate degree at IAG, the Institute of Aerodynamics and Gas Dynamics, and he also studies aerospace engineering. And last but not least, Andreas Herrick, as a member of the ACC2011, was a participant of the Chicago Challenge 2007, and as a personal model aviator and a successful F3B aviator, and is in the final stage of his doctorate degree also at IAG. So that's our time schedule. You all have also in your booklet. Not here of 12 points. We got a strict schedule, so we have to cut you off at 20 minutes if you're talking too long, and be sure that your group flight also in your 15 minutes, that you can present it also in these 15 minutes. The technical check will be during the presentation out there in the hall, downstairs on this floor, and there you get the whole information out there. All here in the room, and here on the screen you see the schedule for the presentations. As you can see, the presentations are just done for the team members, and the technical checks are always will be in a block of 4 teams. You can always look down there, be sure that you are ready for a technical check and your presentations, but we will also give you some information between the presentations who are the next 4 for the technical check. For the presentations, it would be a lot quicker if at the beginning of the coffee break, the first block of teams who present, so 1 to 14, come down here with their presentations and copy them on our laptop so we can switch much.
Hello everybody, I'm Jonas from ACC2011 Stuttgart, and I'll tell you something about security. Here you can see a map of our airfield. The flight sector is marked red. It's a half circle with 300 meters radius. You must not leave it with your plane. Also, never cross the runway in the direction of the spectators or the teams. The blue runway is a manned airfield. While during our competitions, men carrying titles are taking off and landing there. They have priority. We have to interrupt flights if there is an airplane taking off or landing. And of course, obey to the orders of the marshals, everyone in a red or orange t-shirt. Please do what they say. And of course, don't enter the flight sector or the runway without permission of the flight control. For example, if your plane crashes, don't just walk into the flight sector, ask for permission. Transmitters operating with 5 MHz will be collected and to the flight control and only handed out for flights or for tests. And please return the transmitters immediately after the flight or the test. Okay, something special. For traditional reasons, every pilot has to become a member of ACC2011 Stuttgart for the weekend. That's because of the law is like this. At the inspections, there's a form every pilot has to sign for the membership, but there are no obligations or fees for that membership, and it will be cancelled after the competition. Another funny fact, we have to inform you about this bird. There's a population of this bird on the grass part of the flight sector, and please don't step on them or disturb them. Okay, that's that. So, finally, the competition. We'll try to do as many runs as possible to give every team a chance to fly as much. But we will announce the last run. It might be interesting for tactics, maybe. The payload will be stated on a sheet of paper by the team leaders, and the payload will be announced when all teams have stated it before the flights. The order of the first flights will be according to the team leaders. Later we will change the order. Okay? I wish you good luck, and I hope your planes will remain in one piece. Thank you.
Team 18 and 21, they need you for technical inspection. Team 18 and 21. Good morning everyone again. First I would like to thank our host for such a warm welcome and introduction. I'm honored to be first to open this competition. Some say it's a pressure, I say it's an honor. We are Who's Black Eagle team. We are all students of aeronautical engineering on Faculty of Mechanical Engineering and Naval Architecture. Try to find a simple configuration that we would be capable to make, and that would be, and it would have desired performance and aerodynamics. So we use the conventional configuration with rectangular wing, dragger propeller, and tricycle landing gear with the nose gear. So, okay. So this is our plan. This is a dark, but it's best we can.
Αυτό πάει να πει overnight, μαλάκα. Overnight. Είναι γλυακό. Αφού ήταν εύκολο. What about landing?
So taking forever.
From Faculty of Engineering. Me and Ruben, we are from Mechanical Engineering, and Bruno and Andre are from Electrical Engineering. So we have a space in our faculty. This is the lab and a wind tunnel that we use to make some tests. And this is our plane. We call it junk lifter. It's a little bit different of the plane that we put in the report, because this is one of the first plane we used. He had a fuselage box shape. We decided to use a tail with airflow profile, but we had some problems with it. Unstable flight, it was too heavy. We didn't have any control of the plane, so we decided to do another one. And this is the final plane. It has a simple structure of aluminum tubes. It is, as already told, this is the first time that he fired, but it crashed. Now it's the second. Yeah, a little unstable flight. At this moment, we didn't have any control of the plane, but so here we make some. That's where we work in the. This is another test of the airplane, but not so good, like the other ones. But it is a little bit longer than the others.
Emre from Anatolian Craft Design Team, and today I will present you our Adventure 4 Air Cargo Challenge, the whole design process. So here is our outline. I will mention our team members, our conceptual, preliminary, detailed design processes, manufacturing and tests, and our modifications after flight tests. So this is our team scheme. As you can see, every one of us leaded a special branch during the whole process and added to the other branches. So here, the very first thing we did was to understand the rules. We had a data pool and we checked the restrictions and limitations of the aircraft, and we optimized it. By optimizing the design, we reached the final aircraft. Then, during let me mention preliminary design, critical design parameters. We divided into 3 branches: our aerodynamic, propulsion, and structural. Aerodynamic branch also includes the stability and control branch for our case. So here are the important elements. As you can see, takeoff limitations, stall speed, express pressure, wing area, and airfoil options for aerodynamic design, battery selection and optimizations for propulsion, and structural design includes spar locations, material selection, and box. So first of all, airfoil selection. We made a research about 5 main airfoils with high. There is an important thing about our landing. Our pilot does like to land on crops, and you will see it. I couldn't find plastic, you see that.
My name is Michael Johal, and I have an honor to present Air Cargo Challenge project from Rzeszów University of Technology. Here are my friends from team. Their names are on the screen. So let's start. We have our contents of presentation. We just start with introduction and go through all these points from conceptual design to detailed design. So as you can see, it can fly and it's stable. So thank you for your attention. If you have any questions, I would like to answer. So I hope it's enough because we have a little of time. So I would like to finish here.
Flight, sorry. Here you see that we lift 4 plates. Each plate is 0.8 kilograms, so 3.2 kilograms. Here we see how we lock the cargo in the cargo bay with scratch tapes. It's very easy, very safe way. Fast forward. Here's your inspection before the flight again. Take off. We don't push the motor here. We have lifted 6.5 kilograms. I have a video if you want to show you when you ask me. No, it was landing. I think. Here's landing. So, okay, I want to thank you and wish good luck to all participants. We take off cargo, 4 kilos cargo. In this the distance about start was 50 meters. Our construction is easy to assembly. We use folding propeller like in motor-guided air models, and we tested 3 types of propellers in special state. We use propellers 12 and 8.
University of Bucharest, and I'm here to represent a team of 6 members, which also studied at faculty. On the right here we have our pilot, and these are the other guys that help with the construction and design. Today I'm going to start with requirements, then on with aerodynamics, aircraft configuration, aircraft structure, performance, manufacturing, and at the end the flying test. These are the restrictions which are imposed by the competition regulations, which you already know. Configuration assignment, we analyzed the classic monoplane, the Fanart, Vietnamese classic, flying wing, and due to very high gradient weight and stability, we chose the monoplane classic design. This also offers us a very low weight. Going on with the airfoil, we searched for airfoils that were very good at high lift capabilities and low reynolds numbers. We opted for reynolds number between 150,000 to 300,000, and this is the one that came up the best. These are the characteristics. The airfoil was simulated in the FLR 5 software, and also these are the profile, and also the distribution of pressure was calculated in ANSYS, computational design. The wing geometry was, we also studied different types of wing geometry, starting from trapeze shaped, rectangular shaped, elliptical. The elliptical gave us the best results, lowest induced drag, and we tried to achieve a shape that most resembles the elliptical shape. Thus, our wing is made out of 3 parts. The main wing, center one, which is rectangular shape, and the two wingtips, which are trapeze shaped. Our hydro angle is close to 0 due to unnecessary weights in the mounting bracket. This is the wing spot I made in Mathcad. Vertical and horizontal stabilizers. The horizontal stabilizer is an all-moving horizontal stabilizer. We chose this one because it offered a lower weight compared to the classical one, and also a greater effect, and we could decrease the surface. And the horizontal, the vertical one is a classic construction. These are horizontal and vertical polars. The profile used was NACA 0012. It's very easy to reproduce for airfoil. That's the main reason why we use it. This is the fuselage. It's made from two main parts: the nose of the fuselage and the carbon rod, which is the tail. The nose of the fuselage is classic wood and pine wood and balsa wood construction. Pine wood plywood panels. In the propeller selection, we used software that simulated engine performance and propeller performance, and we studied 3 types of the propellers, or these 3 came up the best. These are some graphs shown by the software, and this is our thrust versus speed versus velocity test, which is what is in our aerodynamic tunnel at our factory. This is the equilibrium polar, the whole plane. Flight envelope. Maximum load factor is 2.1. The main structure is built out of mostly balsa wood and carbon fiber. Wherever we needed joints or lightweight pieces, we used aluminium. The main wing is made out of a debox, carbon debox structure, right? And uses carbon fiber spars with balsa wood ribs. We did some stress calculations on a 3D model, which we tested in ANSYS. Here on the left you can see here, it's the force distribution from the lift distribution. This we took it out of XFLR software. We also tested a model of wing which is of similar construction and compared the results with the one ANSYS. These are some performances. Time characteristics, available thrust versus available speed, and altitude versus speed, flight and level. Static stability. The takeoff and landing. The takeoff, we use a formula to estimate the takeoff distance, which we took into consideration friction between wheels and also mass and accelerations. The distance was about 55.1 meters, which came pretty close to the actual thing, which when we started testing it. This is the payload over density graph for every altitude. Yeah. You can see at higher altitudes there is a smaller lift force, and therefore we can carry a lot less is the manufacturing part. You can see down the left is when we're building ourselves the carbon fiber D-box. And here we're making carbon sheets for these parts. Assembling the wing. Also the tail. And right here is our first day of flight. Unfortunately, we only have a picture of that, but we have some more evidence of the flight. These are the flight tests. We also made some modifications, some improvements along the way. We had about 4 days of flight testing. And a few of those modifications were the landing gear, which is no longer 2-wheel landing gear, it's a 3-wheel landing gear. The rudder has a bigger rudder. And also the horizontal stabilizer has been increased. The reason why we increased the horizontal stabilizer is, well, at the first flight it handled really well, but when we started adding weight, over 2 or 3 kilograms, we kind of lost control when coming down for a landing, and we couldn't pull it up. That was a 1.2 kilogram flight. Also, initially, we had a heavier wing, which combined with the rest of the model came close to 2 kilograms. Our second version, we cut short on resin and a few other things. We managed to pull that out. It's a 3.3 kilogram flight. This is the first run, and there is a second. This is the final one of the day. It's, the heaviest load on that day. The heaviest load we lifted so far with it, it's close to 6.5 kilograms.